think we have a complete disregard for our environments.
Water's drying up, which is kind of silly because it rains all the time everywhere.
35 to 38% of the greenhouse gases are produced by just 5 materials.
सरकार हमेशा बहुत अच्छी स्कीम्स लाता है, बट वो लोगों तक नहीं पहुंचती है.
There's so much research around solutions, so where is that gap?
We have found more than 25 ways of building earthquake-safe buildings without using cement.
What will people pay for? People will pay for design.
We thought of coming up with a model solution that can be easily replicated.
With analytical tools available, it really makes sense to use data to optimize design.
We're facing a climate emergency, but it's not irreversible if we act swiftly and decisively.
I wanted to build an Uber for waste. Every bit of waste is a resource.
The footprint of this project is hardly 20% of the entire site because the unbuilt is as important as the built.
Very quickly I learned that the person making the big decisions was the person who is controlling the money.
I think adaptive comfort has to come back into picture.
You have to talk to the people. If you want the project to reach somewhere, you have to involve them in the process.
अगर कोई बहन एम्पावर हुई तो वो बेनिफिट पूरे एंटायर फैमिली को मिलेगा.
Tiling industry is massive. Even if you change 10% of it, there's a huge carbon emission saving that we would do.
Now this is suddenly sustainability that is offered not at a premium.
Disruption can bring the world to its knees, but it can also breed innovation. Our world today is faced with unprecedented challenges. The building industry is responsible for some of the major problems in the world, but it also holds some critical solutions. For architects and designers working at the forefront, sustainability is a non-negotiable. But without concrete, evidence-based action, we run the risk of our solutions being ineffective, inaccurate, and sometimes actually contributing to the problems that they're trying to solve for. Data is critical to informed decision-making, and that's the theme of our conversation today. Today we have with us Gurneet Singh, Director of Environmental Design Solutions, a sustainability advisory firm with offices in Delhi, Mumbai, Pune, and Bangalore. Over the last 20 years, EDS has consulted with some of the leading architects, planners, and governments all across the world on more than 500 projects, from master planning and policy making to buildings and building components. So Gurneet, today I want to start with your story. Where did this interest in sustainability begin?
Yeah, so it's an interesting journey. So when green building movement was just starting in India, I was in my final year of bachelor's, and there I got this newspaper advertisement about having this building science course, which was launched by IIT Hyderabad. So I joined that course, and when I was in final year of that, fortunately, EDS was starting this journey in India with the vision of providing, high-end analytical support to architects, designers, to consultants. So I joined that, and then after that there was no looking back. Got a wonderful opportunity to work on different kinds of projects, starting from varying from policy level to building level certification and looking into post-occupancy, and also got the opportunity to work on various geographies and with various stalwarts of design community which are there.
I think with your work, the one thing that actually comes out the most is the significance of data in evidence-based design and planning. Yes. So what do you think data can do to catalyze sustainable design?
So when we are looking at building level thing, data definitely plays a very, very important role, because that allows or helps the design team to take an informed decision. Otherwise, most of the decisions are either they have gained experience over like 20 or 30 years, or it's just thumb rule calculation. We were working in Organic India factory in Lucknow, where the storage, the raw material storage building had this north light, right? And by intuition, it makes sense to, you know, add solar panels on the south facing opaque wall, opaque roof. So, but when we did an analysis, what we found that the adjoining building for that project, it was casting shadow, and the roof was actually not usable, was not appropriate for you know, putting in solar panels at that point. So that's why, I mean, with analytical tools available, with now this power coming to your personal computer, it really makes sense to simulate and to analyze and to use data to optimize design.
I think that's very interesting, you know, how data and simulation and analysis can make you challenge preconceived notions that you begin a project with sometimes. You've worked on multiple scales, you know, from the macro urban scale to the building component and product scale. Let's sort of move to the building level.
Yes.
And I think your work with the Organic India factory is a great example of how, if you're involved as a consultant through the early stages of the project, how it can actually change the game completely.
So one of the key aspects of sustainability, or in fact any design, whether it's a product design, whether you are designing a car or anything, is that you set your goals from the very starting, right? The early on you come into picture, or you decide that you want to go with sustainability or optimization, you will get a better product, better building at minimum or low cost or no cost. As you proceed into the design phase, and you know, the later you decide that, okay, now I want to incorporate sustainability, there are only limited avenues where you can include sustainability. So from that perspective, it's difficult, and sometimes it also becomes very costly. So in most of our projects, we try to you know, work with architects, owners, consultant from the very starting of the project, so that each and every consultant are aware of the goal that the project is want to achieve. So they take that factor into account and work on the design. So Organic India is a great project where, again, great team, both architects, everyone contributed to that, looking into each building orientation, looking into what is the optimum window wall ratio, what are the optimum shading strategies. So if you see that building and all the factory buildings around that building, you will see a stark difference. All the buildings are normal shed kind of building, which, you know, generally people prefer to go with the shed, you know, so that it can allow them to quickly start their operations, factory operations. But this building always stands out from that pack, and whole design was done in a way so that an occupant or the worker who is working in that factory also get access to areas where they can relax, are connected to green area. We have tried to align it around a courtyard. You can see trees, you can see plants, you can see green area in that. So every room has been analyzed and calculated to see that they have some or the other access to greenery, which anyways always we all know contributes to wellness and health feel.
So this was an example where you were involved right from the get-go.
Yes.
But we live in a country where we have a huge building stock that lies with us as potential to reuse, to recycle. And, you know, we're talking about the circular economy these days. This is something that we have to do. It's the more sustainable thing to do. So how do you deal with the challenge of working with an existing building and adapting it to sort of create better performance?
When we approach any existing building, we definitely get into that aspect. We try to analyze and give that input and work with different stakeholders to see whether those are feasible or not, and quantify the benefits of that. So we have a team who looks into detailed audit of the building to understand the potential savings if we replace certain aspects of that building. Any existing building, let's say, will be at least 10 years old. You know, every 6 months there is a new technology that is coming in, and you can imagine a building having a system, lighting system or the HVAC system which is 10 years old, and how the present technology, how efficient that will be. So definitely there is a huge potential to look into the operational energy part in terms of design.
And I think I also want to move to the building component scale. it feels like it wouldn't actually have a huge impact. But your work actually shows that it can prove to be completely, game changing.
In one of the project, the architect came to us and said that they want to shade the building in a way that there is no direct sun coming in. So we worked with the architect, we gave certain angles, design, and they started implementing the shading. So the complete building was shaded. There was not even a single hour that the sun was entering into the space. The workers who were working there, interior interior team, they preferred working in that area which has shading because it provided them a thermal comfort compared to the other spheres. On the other aspect, when we talk about active system has huge benefit and huge savings related to whether it's lighting or HVAC optimization, chiller optimization itself. Looking into which is the best chiller based on your building profile, building occupancy, operation of things. If you combine all this measure, any building with all this measure or sustainable building will not have more than 2 years as a payback period. So
and that's amazing.
That's
I think that's what people need to know.
Yeah, and in fact, I would say if from the very first day, like the project we did in Organic India, if you are aligned towards sustainability, then there will be no additional cost because you are optimizing your design. You are also bringing down your capital investment in terms of the amount of chiller required, the tonnage of chiller required. So from that perspective, though people ask me that what is the payback, and I have to tell them at least 2 years. But if you ask me if any project or any product is following this optimization route, there won't be any additional cost if they adopt all this sustainability.
We are the sustainability consultant involved in the project, and there were 3 major things that we have to look on for the facade optimization. First is the daylight analysis. We need to design a facade that actually enhances or improves the daylight performance of the building, but at the same time reduces the heat gain. So that was a challenge. So first, we optimized the wall to window ratio. We tried to keep it below 40%. We have achieved maximum 98% of useful daylight SDA inside the spaces. Now we have to also analyze and provide the best angles that can help to reduce the glare into the building, and with the help of the computational tools, we provided them the optimum angle that should be provided for the vertical fins. We have also worked on the light shelves design that helps us to penetrate the light and reflect back into the deeper spaces. So these interventions help us to achieve daylight area of 98% and cut down the glare to only 1%, and at the same time also improve the thermal performance of the building and help us to restrict the heat gain to 0.75 watt per square feet.
From a building component level, let's move back to the macro level. Our population is rising, our rate of migration to cities is rising.
Right.
And while planners are working on developing an alternate model for planning, I think your work actually shows that, or questions, if you already have this migration, how do you deal with it? And you worked on a decarbonization plan for the Maharashtra government. Yes. Can you talk a little bit about that?
Yeah, so that was an interesting project where we were given this task to develop a roadmap again for looking into decarbonization of 43 cities in Maharashtra state. So in this task, we worked with the Maharashtra government, Maharashtra state, to look into what are the aspects. We looked into the data to see which are the biggest consumer of electricity or GHG carbon emission, and based on the analytics, derived a roadmap that by 2040 or by 2030 you need to have certain codes in place or certain policies in place, capacity building should be in place, and by next decade you need to look into other aspects. Again, those are specific to each and every city so that they can adopt and can move forward for decarbonization of their whole state.
So around 6 months back, we have engaged in a development of a group housing project for a corporate in Andhra Pradesh. We were required by the client to look at temperature scenarios in the year 2050 and 2075 and ensure that the thermal comfort conditions are are still within the permissible limits as on today. To look at the solutions of this unique problem, we were required to look at all the material options available today, their comparative performances, and their direct impact on thermal comfort. And each of these options were then evaluated for 365 days, 24 hours thermal performance of the spaces, and then compared with each other. So overall, there were around 18 different combinations which were evaluated. So this resulted in approximately 1400 hours of lesser discomfort as on date, around 1000 hours of less discomfort in 2050, and around 600 less discomfort hours in 2075. This also means that the occupants will be less reliant on active mechanical systems for years to come, and will result in a significant amount of energy savings throughout the lifespan of the building.
That brings up something to my mind actually. You know, there's this project that you're working on in Rajasthan.
Yes.
And where again you were dealing with heat risk.
Right.
Can you talk a little bit about that project?
Yeah, so that was again an interesting application of simulation and analysis, where the whole idea was to protect that development from the summer heat waves. So while brainstorming, the idea came that, okay, why not let's try to protect it with a berm. The thought was that since there will be sand that will be excavating, why not use that to create that berm? So then the question came whether that berm will be effective or not. What should be the appropriate height, width, or the profile of that berm? So there, this simulation analysis at a master plan level helped us in defining the profile, the height, and the depth of that berm.
So the analysis that we carried out was using CFD simulation, which is computational fluid dynamics, which uses numerical equations to solve how the fluid will flow over a particular boundary conditions. We looked at how wind is coming from the southwest direction in peak summer and how it is flowing over the building. So idea is to reduce the wind speed at the building level from 8 meters per second to something like 1 or 2 meters per second. So we carried out different iterations with different heights to see how the wind is flowing over that wall and how much farther it is carrying and depositing the sand or the dust. So the design philosophy that was followed was to design low-rise buildings, so basically ground plus 2 stories. And then there is a semicircular earth wall which protects those buildings from the wind. So it provides a wind shelter and also it provides a dust shelters to the buildings.
I also want to touch upon this really interesting thing that EDS does, which is spread the word about sustainability.
Yes.
You've been teaching and holding courses for the last, I think, 15 plus years.
This one thing that I learned during my college, I was a teaching assistant, is that if you want to learn any topic, it's important to, you just teach that because the kind of questions, the kind of doubts that you come across. That other thing that was in mind was to share the knowledge, to share the practical issues that you face with the world, because generally all these courses or the programs are more on the theoretical side. So I saw that with this thing you can bridge that gap of theory and practicality, the issues that you face. So if as a whole we are looking at optimizing and looking into sustainability and want people to adopt sustainability, we also need to share the knowledge, because ultimately at the end of the day we have only one world, and we need to take initiative to save in whichever way possible, whether it's through capacity awareness or capacity building. So that basically motivated me.
I think more than sometimes formal training, what also helps is exploration and experimentation. And you've also set up digital tools for architects and designers to use on their own time and to sort of learn with it. And sometimes just figure out a way to convince your client by using data. So 𝗗𝗂𝗿𝗂𝗀𝗃, for instance, is a great example of that. Can you talk a little bit about that?
Yeah, so generally and that's the challenge I think everyone is also facing, that if they want to go for sustainability, they need to know those analytical tools, they need to know the intricacies of those tools. And sometimes the budget, or sometimes there are other constraints which does not allow. So from the very starting, we have been working on this model where you have huge data with you, and you try to have regression curves and other information build on those curves, so that you don't need to get into simulation. You can just feed in certain 5 or 6 parameter, and based on the trained data, it gives you an output. So EcoNivas was something which was done on the similar lines, where a huge data set was created through simulation outputs, and then that data set was used to prepare to have a interface which can be used by any architect. Even a owner can use that. It's just a drag and drop. They can drag and drop the various, we call it as energy conservation measures, various alternatives, and see the impact on energy usage for that building, for similar kind of building. Yeah, definitely it is not that it will give you that much of accuracy, but it is still within 5% of accuracy, and can be used to take an informed decision, to take a call on whether they want to go with efficient glass versus going with insulation on the roof. So it's a very easy to use tool, again build on data at the back end and regression curves.
Our industry today actually runs on making lives easier for architects and designers, and even users and consumers, for instance, right? And the tool that's employed most is these labels and standards and certifications.
Right.
What is your opinion on some of these ratings and sort of certification systems?
I really appreciate the work these rating systems have been doing. They were able to bring a market shift in green building market in India. So the one thing that I like about these rating system is that they are able to define a goal for the team. They are able to give a framework and bring in discipline into the team, because generally what happens is that as you proceed in a design, because of certain constraints, you try to dilute some of the sustainability initiative. But with this rating systems, if you are committed to certain initiative and you have to prove, you have to document that, you have to submit it, there is no place to hide or even dilute that thing. So that is what I like about these rating system. One thing that I would like now, and with this, these rating systems are also updating themselves as they are moving forward with new things. Now all the rating systems are talking about equity, diversity, inclusion. They are also talking about embodied carbon factor, which were not there when we
So they're expanding their scope.
They're expanding their scope. So that again is something good. I have also worked on ESG, and one of the important thing that I have come across when we were working on ESG is disclosure. Right, there you have to disclose each and every aspect in terms of energy use, water and other things. So I think that is one aspect that these rating system can adopt or owner can look into, is disclosing their initiative to the outside world. This will also kind of help in avoiding any greenwashing, because since you are disclosing it to outside world, anyone have access to that information, and you need to make sure that you are disclosing the right value to the outside world.
And I think this also requires a very fundamental shift in our culture of designing. I feel like as architects and designers, we're all perfectionists. You want the 100% renewable, 100% recyclable, and they've almost become marketing gimmicks today. So I think there needs to be a sense of responsibility and accountability there, where any step forward is a good thing. Right. And I feel like we need to appreciate that.
Yes.
And I think systems that are so inclusive and are also expanding their scope and giving opportunity to people to actually justify the use of new approaches, unconventional materials. And I think that sort of experimentation is required these days, because otherwise, we'll all be slaves to the system,
right?
And we're not actually innovating anymore.
Yes. So that is an important part. The day you stop innovating, that means you are dead, right? So, and it applies to any field, that there is a need to invest in research. That is something what I feel is also lacking in building industry or corporate industry. So just comparing it with a product, right? So if you take an iPhone or any car, there is a department who looks into research and development of that product, right? They try to look into different technologies to make the product, to improve the product, whether its own design or its own operation. Somehow that thing is lacking in building industry.
Your work sometimes goes beyond just setting these roadmaps and into setting benchmarks, setting new codes and labels and standards for buildings to be evaluated by. You've worked on the ECBC, for instance, in India. Right. Can you talk a little bit about how you see Western models as different from Indian models?
Yeah, so I would say these are two different worlds altogether. So the South Asian or Indian thing is more on adaptive strategies, and if you see our old buildings, I think they are all towards adaptive strategies and looking into, and we also as an occupant are also more used to having naturally ventilated space or having a higher temperature part. But there are certain things that that are good at on that level. We should adopt that, and we should learn from them and adopt that to our local context in this perspective.
So in this update, we have done the market assessment and developed 16 building typologies, which is based on current construction practice, including building how envelope is developed, constructed, how is the lighting power density or lighting efficiency in the market, and air conditioning systems as well. So second goal is to make it easy to implement, easy to understand by the different stakeholders like builders, architects and design teams. So we have created different options, compliance options, which include some prescriptive approaches, and there are compliance related to simulation or more detailed analysis based approaches in each sections. By using energy conservation building code, by 2030, India could save approximately 300 billion units of electricity, and it could also reduce 15 gigawatt electrical demand, which reduces the plant electrical plant generation capacities, and also abate 250 metric ton of CO2 emissions.
As we're ending this conversation, I think I want to look at you as somebody who's going to be here for the long run, right? What do you think are the leaps that the industry you feel will take in the next 20 years, 30 years that could change the way we look at sustainability, or that change the way we evaluate, performance?
So when I started my career, I worked on text-based simulation tools. So where you need to, if I have to create a 3D geometry of this space, I need to put in the coordinates on that front. And then I saw transition to tools which I got good interface, and then transitioning to cloud-based tools which were able to do parametric analysis with a click within seconds. Now we at EDS are also exploring the possibility of integrating AI and ML into these things. Now we have got huge data sets with us. We have got huge different the quantum of simulation models that we have. So we are trying to create surrogate models and looking into generating these models from synthetic data and trying to utilize that in optimizing studies. And I think AI and ML is the next. We have already seen. These are kind of digital twins which can help you with prediction, real time your energy usage, can help you also define your control strategies. Okay, so I have so much of occupancy in this time, outdoor temperature is so much. What should be the ideal control set points for my chiller, right? The application of AI and ML, and many of you are using it. I think in the next few years, how AI and ML can help the building industry in optimizing in operation of the building also, because that again is very, very important. You have designed the building, but you need to also operate it efficiently. So rather than doing a simulation which takes 10-15 minutes, these models can quickly run simulation and give you in a second that, okay.
And I think our world is evolving so quickly today that you need that sort of...
Exactly. So that we need to go through that path.
I think, Gurneet, this has been a lovely conversation, very insightful. Thank you so much for sitting down with us for this today. I think we've had a very insightful conversation today about how analysis, assessment, and data are critical to defining a more sustainable future for us today. Our focus remains on sustainability in the series, and we'll see you in the next one.